Well, good day, sixth graders, and welcome to Chapter 10. This is Mrs. Dubay coming to you live from room 21. And just a couple of questions before we get started. What is a parallelogram? Something you should know. And how do you find the area of a square? We'll be exploring these in lesson 10.1, but sometimes I think if I just throw it at you first thing, then you'll be more apt to listen. So what is a parallelogram? Well, base word parallel. So a parallelogram is a figure that has two sets of parallel sides. So for instance, this square has one set of parallel sides, the top and bottom, and what that means is they will never meet. So if you extended these sides out, they will never meet. That's what makes them parallel. They will always be the same distance apart, regardless. They will never cross. Okay, so that's what makes those parallel. Now, they also have a second set of parallel sides. Okay, so again, these sides will never cross, and they will always be equidistant from each other. Okay, so that's what makes parallel lines parallel. They will never cross, and they are opposite of each other. Okay, so just something to think about, food for thought. And the other reason I put this up here is how do you find the area of a square? Because now being in sixth grade, we all know area equals length times width. But it seems silly to say that with a square, even though you can use that formula. So the length of the square times the width of the square. But you're also going to see it written like this. Take a second. Why would I write the formula for area of a square as A equals S squared? Well, S stands for side, and we all know the definition of a square is that all the sides are of equal length. So if this is 6 inches and this is 6 inches, I guess technically we'd call this the length and call this the width. So the area of this square would be 36. Or you can just take one side, plug it in for the S, and square it, and you'll still get 36. So just a little thing to notice before we get started here. So please turn to page 533 in your book, and we will begin lesson 10.1. Area of parallelograms, essential question. How can you find the area of parallelograms? Okay, connect. The area of a figure is the measure of the number of unit squares needed to cover it without any gaps or overlaps. So you have a figure and you're trying to find the area of it. There will be a certain number of unit squares inside of it. So the area is how many are needed to cover it without any gaps or overlaps. The area of a rectangle is the product of the length and the width. Of course, product we all know means multiply. If you don't know that, you need to pause the video for about 3 minutes and say it to yourself over and over and over again until you know it. The rectangle shown has an area of 12 square units, so referring to this one. For a rectangle with length L, see the italics, goes with the word before it, and width W, here's the formula, or here's the formula. In sixth grade, remember, we usually write it like this. We don't like use the multiply sign because then sometimes we think that's a variable x. So we much prefer you writing it like this. Alrighty, so if you look at this rectangle over here, typically we don't see these grid lines when we're doing our area. They usually just give us the dimensions. But it's good to look at it this way because it's showing you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of this rectangle is 12 square units. The reason we use square units is because it's a two-dimensional figure. It has a length and it has a width, but there's no depth to it. That would make it three-dimensional. Okay, so we have 4 units along the top and 3 along the bottom. So to find this area to cover with no gaps or overlaps, we would just multiply the 4 times the 3. Now it says, recall that a rectangle is a special type of parallelogram. A parallelogram is a quadrilateral, quad meaning four-sided, with two pairs of parallel sides, which we just went over in the last slide. Okay, lots of definitions and vocabulary in this chapter 10. So you need to know these. If not, pause it, study it, come back to it. All right, so let's look at a parallelogram. So a square is a parallelogram, a rectangle is a parallelogram, and we also have this figure, which typically we call a parallelogram, right? Because it has two sets of parallel sides. The blues will never touch. They'll always be equidistant from each other. The reds will never touch. They'll always be equidistant from each other. So we have two sets of parallel sides. Some students get into trouble because they say there are two parallel sides, and they forget this very important word. There aren't just two parallel sides, there are two sets of parallel sides. All right, so for this formula for a parallelogram, we call it area equals base times height. And we call it that because, as you notice, the two blue sides are slanted. Okay, so we need a height in order to do the formula area equals base times height, which, by the way, is area equal, it's the same as length times width. Okay, and I'll show you how. So if we were to cut off, so let me bring this up. Say we were to cut off this triangle from this side. Okay, so I'm just going to pull that up there. And so the dotted line will always refer to the height because it makes a perpendicular line to the base, which is a 90-degree angle, right? Hopefully we all know that too. All right, so we know it's the height because typically it's dotted and it's perpendicular to the base or to another side. Okay, so just going to take, so what we're going to do is cut off this, whoops, we're going to cut this off and bring it to this side. Okay, so by cutting that off, I have to remove these, right? And I'm just going to replace it with this. Okay, and if you kind of don't look at this line, what are we left with here? We have a rectangle, right? So if you lop off one side of the slanted rectangle and plop it on the other side, now you have a rectangle. That's why the formula is the same. It's just still length times width. But for the slanted rectangle or the parallelogram that looks like a slanted rectangle, this is the formula we use, base times height. And so notice the dotted line is still going to be the height, and then this will still be the base or the length. Okay, so hopefully you understood that. If not, you can always rewind it and go back. That's the beauty of the flipped classroom. Okay, moving on to the next page. Example 1. Use the formula A equals base times height to find the area of the parallelogram. Well, every time you have one of these figures, you don't have to get out your scissors and you don't have to cut off this and replace it over here to make yourself a nice rectangle. All right, so we're leaping from that because you can kind of just visualize it and know. Plus, our formula is base times height. Well, like I told you, height will be the dotted line and it will be perpendicular or at a 90-degree angle with the base. Okay, so the first thing you're going to do every single time you're finding area and you're using a formula, you must write the formula first. I'm pausing so that you can absorb that for a second. So we're always going to write the formula first. We're always going to have our little box of goodness over here as well, and we're going to put the formula letters inside because we need to know what we have. So it says find the area. So I'm just going to keep the A because that's what we're finding. That's the question mark. Now the base is 6.3, so I'm going to fill that in. And the height is 2.1, so I'm going to fill that in. Then I'm going to come back to my formula. I know this seems silly, but this is how we want it done, right, Mr. Damiani? So the base will get parentheses and the height will get parentheses because we know when two variables are stuck together like that, it means multiply. We're finding the product So we're going to take our B and fill it in for the B. We're going to take our H and fill it in for the H. Okay, so they have that right here. They filled in the B. Okay, and then we have to fill in what the H is, which is 2.1. And then when we multiply that together, and you have to remember how to multiply decimals, you get 13 and 23/100 square meters. Every time you're dealing with area, your units will be in square meters, and another way to write this would be meters squared. Remember, the squared is the exponent 2. All right, moving on to example 2 is what we talked about before. A square is a special rectangle in which the length and the width are the same. So you don't have to use base times height or length times width. You can just use A equals side squared because the sides are the same. So find the area of a square with sides measuring 9.5. Again, we're going to write the formula, and we're just using S squared because the S's are the same, and S stands for side. Okay, and we're just going to square the side. So we're just going to plug in 9.5. All right, now, don't forget your little box of goodness, which I just forgot. We have A, that's what we're trying to find out, and we have the side length, which is 9.5, and we're going to plug it in, and we're going to square it. And when we square 9.5, we get 90 and 25/100. Remember, 9.5 squared is not 9.5 times 2. So if you do use this formula for the area of a square and you're squaring it, we want to see that you remember that it's 9.5 times 9.5. So you can put that right underneath. So the area of the square is 90 and 25/100 centimeters squared, because when we're dealing with area, we use squared or to the second power. All right, looking at example 3. A parallelogram has an area of 98 square feet and a base of 14 feet. What is the height of the parallelogram? Well, this one's a little trickier. We start with a formula, and we do our box of goodness. So we're going to put A, B, and H from our formula. But this time, it's telling us the area, right? It's telling us the area, and it's telling us the base, which is right here. We have to find the height. So height is going to stay height. Then we're just going to plug in. B gets parentheses, H gets parentheses, and now we're just plugging in. B is 14, H, we don't know. But what we do know is that to get this H by itself, we see multiply, so we have to do divide, which means we have to divide each side by 14. And when we divide each side by 14, we get 7, so the height of the parallelogram is 7 feet. I can tell you're all being very good listeners. I just know, I can feel it. So what I'd like you to do is please do number 2 under the share and show, number 3 under the share and show, and I want you to do one where we already know the area and you're trying to find the height. So let's do number 6. So for tomorrow morning, please do 2, 3, and 6. Show your work on loose leaf. Here's why. Don't get angry. You're showing it on loose leaf because, remember, you have to write out the formula, have your box of goodness where you're writing down each letter and what each one equals so you know what you're finding. Then you're plugging in, and then you're copying and solving. So you're doing all this work, and we want to make sure you have enough room. Also, sticky note anything you don't understand. And also, please write a sticky note of what the main idea of the lesson was. And we'll be checking for these 5 things: 2, 3, 6, sticky, sticky. Great, everybody. Hope you have a nice afternoon, and we'll see you on the flip side.